Okay, so we're going to do question 4.9. So assume that Gabrielle faces much the same situation as Daniel, having a fixed amount of money M, which she can use to buy consumption bundle B, C, consisting of quantities B of bread and C of cheese. P, B, and PC are the prices of bread and cheese. And Gabrielle's preferences are well behaved. Okay, so part A of a diagram asking you to sketch the consumer's affordable set. Okay, so we have okay, so PB and PC are the prices of the two goods and income M. Okay, so we know that from here we should be able to write out a budget constraint for the bundle B and C. Okay, so budget constraint is going to be the price of bread times the amount of bread, which is B unit of bread, okay, plus the price of cheese times C units of cheese that the consumer is going to consume, and that has to be equal to the income. So this is the budget constraint. Okay, so we just have to draw that on a diagram, which is very straightforward. Okay, so over here I got a diagram where again I put C on a vertical and B on a horizontal. I got 0 over here. Now I do not know the values of PB, PC, and M, so again I just plot randomly on a diagram. Okay, knowing that the horizontal intercept again is just going to be the M divided by PB, and the vertical intercept is just M divided by PC. Okay, and the slope of the budget constraint, okay, equal to negative PB on PC, right? So horizontal intercept M on PB, vertical intercept M on PC. Okay, now again you just pick any two random points because we do not know the values of these, so anywhere is fine. Okay, so this is my budget constraint, and the question asking you to show the affordable set. Now affordable set is basically the budget set. Okay, so the budget set again is anything below the budget constraint, including the budget constraint, is called a budget set. Okay, we already know that from before, and so affordable set is just another name of the budget set. Okay, so affordable set is just the same as the budget set, okay, which is anything below the budget constraint, including the budget constraint. So if I use the yellow color to highlight it, and it's going to be this triangle over here below budget constraint. Okay. Alright, so this is the affordable set. So anything in the yellow area, including the black line, is affordable set. Okay, so which is the yellow, okay, shaded area. Okay, including the black line. Okay. Alright, so part B asking you assume that Gabrielle chooses a consumption bundle M, including BM and CM, which lies on her budget constraint, okay, which is on the black line, but for which the marginal rate of substitution is greater than the relative price. Okay. So talking about the marginal rate of substitution, we're talking about the slope of the indifferent curve. Okay, now in this case Gabrielle's preferences are well behaved. Okay, therefore her indifferent curves are going to be a well-behaved convex, which is the normal convex curve, representing a well-behaved preference. Okay, so if I want to draw a few indifferent curves for Gabriel's, it's going to be a few convex curve. Okay, nicely, smoothly, just like this. So if I do a few of them like this, okay, so these are the indifferent sets, okay, which is including all the indifferent curves for the consumer. And the higher the curve, the higher the utility. Okay, so the direction of increasing utility is going this way. So the higher the curve, the better for the consumer, or the higher utility the consumer is going to get. Okay, so now the question asking you to illustrate the bundle M on the diagram. So the bundle M is the bundle in which is lying on a budget constraint. Okay, so we know that it has to be on a black line, and the marginal rate of substitution at that point is greater than the relative price. Okay, so what is going to be the location for M? Okay, what can the bundle M be, and where can it be? Okay, so so we know that it has to be on a black line, so that's the first thing. Okay, now the second thing, we know that we have to draw in the sense, or in the way, that the marginal rate of substitution at that point M, it has to be bigger than the price ratio. Okay, so what is the marginal rate of substitution? Now marginal rate of substitution is just basically the rate of decline in consumption of the good in order to exchange for the increase in some other goods. So it's basically the slope of the tangent of the indifferent curves. So it's telling you how many, so it's basically the absolute value of the slope of the tangent of the indifferent curve. So it's telling you how many units of one good, the rate at which the unit of one good has to be declined in order for the consumer to increase the consumption of the other good, such that the consumer is going to be on the same level of utility. Okay, so they are going to be on the same level of indifferent curve. If they want to consume one more units of one good, how many units of the other goods they will have to give up, and that is the marginal rate of substitution. Okay, so it's basically the absolute value of so the marginal rate of substitution is just going to be the absolute value of the slope of the tangent okay of the indifferent curve. Alright, so we know that the slope of the indifferent curve, or the slope of the tangent of indifferent curve, telling you how many units of one good will have to be given up in order to increase, in order for the consumer to consume one more units of the other good, such that the consumer is kept on the same level of utility. Okay, so that is the definition of the slope of the tangent of the indifferent curve. And the marginal rate of substitution is nothing more than just the absolute value of the slope. Okay, so basically just get rid of the negative sign. So when we talk about a marginal rate of substitution, we're talking about a positive value. Okay, so it just the positive value of the slope of the tangent of indifferent curve. Okay. Okay, so I'll just write out a definition over here just in case someone wonder. Okay, so the slope of the tangent of the indifferent curve telling you okay how many units of one wood okay, have to be given up. Okay, for the consumer to consume, okay, one more unit of the other good, okay, such that okay, the consumer is kept okay on the same utility level or on the same indifferent curve. Okay, remember each of the indifferent curve represents a certain level of utility. Okay, so on the same indifferent curve mean everywhere on the indifferent curve represent the same level of utility. Okay, so as we move along the indifferent curve, we basically asking ourselves, if we want to increase one more units of wood B, how many units of wood C that the consumer will have to give up, okay, in order to be on the same level of utility, and that is the slope of the indifferent curve. Okay. Alright, so now the question wants you to draw bundle M such that this marginal rate substitution is bigger than the price ratio. Okay, now we know that the slope of the budget constraint, okay, is equal to negative PB on PC, which is negative of the price ratio. Okay, so therefore the absolute value of the slope of the budget constraint is going to be equal to PB on PC, and that is just the price ratio over here. So what we want to compare is we want to compare this marginal rate of substitution, which is the absolute value of the slope of the tangent of the indifferent curve, and this absolute value of the slope of the budget constraint, which is the price ratio. Okay. So over here I got my budget constraint, the black line, okay, and the slope is PB and PC. Now I want something, I want a bundle M such that at that bundle M, the slope of the indifferent curve is going to be bigger than, the absolute value is bigger than the price ratio. Okay, now we know that the bigger the absolute value of the slope, the steeper the curve is going to be. Okay, so at bundle M, we want the tangent to the indifferent curve to be steeper than the budget line. So if, for example, I pick something like this bundle M over here, which is on the budget line, okay, on the black line, which satisfies what the question asking you to do. Okay, now at bundle M, the tangent is going to be, the tangent of the indifferent curve is going to be, it's going to be this, okay, it's going to be this, it's going to be the blue line. Okay, as you can see, that blue line over here is the tangent of the indifferent curve, okay, at point M. And obviously this blue line is steeper than the black line, which indicates that the absolute value of the slope of the blue line is bigger than the absolute value of the slope of the black line, which is what we want. Okay, we want the slope of the tangent of indifferent curve at this point M, which is marginal rate of substitution, is bigger than the relative price. Okay, so I would say okay, at point M, which is on the budget constraint, okay, I'll say on the black line or the budget constraint, okay, the slope of the blue line, okay, so the absolute value is bigger than, okay, the slope of the black line. Now the slope of the black line is the slope of the budget constraint, which is the price ratio, and the slope of the blue line is the slope of the tangent of the indifferent curve at point M, which is the marginal rate of substitution. Okay, so it's bigger than the price ratio, which is what we want. All right. Okay, how do I know that the slope of the blue line is bigger than the slope of the black line? Like I mentioned before, the steeper the curve, the bigger the absolute value of the slope. Okay, so as you can see, the blue line is steeper than the black line, indicating that the absolute value of the slope of the blue line is bigger than the absolute value of the slope of the black line, which is what we want. Okay, so this point M over here is the point that we want, okay, which is the bundle satisfying what the question asking you to do. Okay, so part C asks you to confirm that Gabrielle can also buy consumption bundles on the indifferent curve IM, for which the acquisition cost part C telling you to confirm that Gabrielle can afford to buy consumption bundles in the preferred set indicated by PM. Okay, so basically with her money, she can buy something better than bundle M. We want to show that. Okay, now what is the preferred set of M? So anything above so anything above so M lying on this indifferent curve over here, so outside this is indifferent curve IC. Okay, now so anything above IC is going to be preferred to bundle M. Okay, because like I said before, the higher the indifferent curve, the better. Okay, so anything above this indifferent curve, so say any point over here is going to be preferred to bundle M, or it's going to be better than bundle M, because bundle M is lying on this indifferent curve. Okay, so anything above this indifferent curve is going to be better than bundle M. So having said that, anything I'll use the red color. Okay, so anything above this indifferent curve over here, okay, so is going to be better than bundle M. So this is called the preferred set of M. Okay, and that's going to be indicated by PM. Alright, so I would say C. Now the red light areas, okay, is the preferred set of M, because containing all the bundles that are lying on a higher indifferent curves than M. Okay. Okay, because it contains all the consumption bundles. Okay, that are lying on higher indifferent curves. Then M. Okay. So as you can see, M is lying on an indifferent curve IC. Now anything in this red line area is going to be on the higher indifferent curve, or it's going to be preferred to bundle M. Now, so with this budget constraint, BC over here, can the consumer buy something better than M? As you can see, any point inside the yellow shaded area, which is affordable, okay, inside the budget set, and also in the red line area is going to be affordable and preferred to M. Okay, so consumer can actually buy something better than bundle M, which is going to give the consumer a higher utility and still affordable. Okay, so I'll say anything okay, so any consumption bundle that are in the yellow okay shaded area containing, remember, or in the budget set, okay, basically containing the black line as well. Okay, so including the black line, and also in the red line area, okay, affordable because it's in the budget set, so it's affordable, okay, and it's going to be better than M, or give the consumer higher utility. Okay, so so Gabrielle actually can afford to buy a consumption bundle in the preferred set. Okay, so in the better area, in the red area, because there's a few points, say over here, whatever, in the red, in the yellow area, okay, and also inside the red area is going to be better than point A. So D, confirm that Gabrielle can also buy consumption bundles on the indifferent curve IM, for which the acquisition cost is going to be smaller than the acquisition cost for bundle M. Okay. Alright, so the question code is indifferent curve corresponding to bundle M is IM. Okay, so that is IM. And so okay, so we want to show that with the same utility IM, which is the same utility as bundle M, it actually can cost the consumer less than what it costs to buy bundle M. Okay, now as you can see, bundle M is lying on the budget set, on the budget constraint or the budget line, which basically means that it costs the consumer a maximum amount of income M to buy the bundle M over here. Okay, anything on the budget line or on the budget constraint is going to cost the consumer the whole amount of income, okay, or the maximum amount of money that the consumer has. So the question actually wants you to show that for the consumer to consume the same utility or on the same indifferent curve IM, it actually can cost the consumer less than the cost at bundle M. Okay, so for example, if I pick a bundle, say somewhere over here, okay, so I would say this is bundle N. Now if I pick bundle N also on the same indifferent curve IM, so this bundle N and bundle M basically giving the consumer exactly the same utility, okay, the same sort of happiness, the same utility. However, how much would bundle N cost? As you can see, if you want to see how much it costs, you can draw the budget line that is going through point N with the same price, PB and PC. Okay, so having said that, it is going to be a straight line use the red color. Okay, so it's going to be a straight line that is going through point N and is going to be parallel to the black line, indicating that we are using the same prices for cheese and bread. Okay, however, it's just the lower cost that is corresponding to the point N over here. So you might got something like this. Okay, so for this point N over here, this red line is going to be the constraint. Okay, it's going to be the budget constraint for the consumer. Or basically it's telling you, so for this red budget constraint, now the horizontal intercept is going to be equal to m dash divided by pb, okay, and m dash divided by pc. Now we already said that pb and pc is staying the same, okay, so that's why the slope of the red line is the same as the slope of the black line, because the price ratio remains the same. The only thing different is that we are having a lower sort of income over here, so it shifted the whole budget constraint downwards. Okay, so corresponding to point N over here, we actually need smaller income to buy, as you can see. Okay, so point N will cost the consumer less, however give the consumer exactly the same utility as point M, because they are staying on the same indifferent curve. Alright, so over here I'll say okay, so the consumer can buy something like bundle N, okay, and with the acquisition cost for bundle N is N, which is equal to okay, with the amount Bn and Cn, and that is going to cost Bp times Bn plus Pc times Cn. So we know that the prices are the same, okay, however the acquisition cost is smaller because it's just equal to m dash, okay, because as you can see the line is now lower than before, indicating that the income that you will have to have in order to buy the bundle Bn and Cn is going to be smaller, okay, so it's smaller than m. Okay, which is the acquisition cost of the bundle M. Okay, so we know that the acquisition cost of the bundle M is equal to M because this bundle M over here is lying on the original budget constraint with the total income of M. Okay, so as you can see, the consumer can buy something that give the consumer the same utility, okay, in something like bundle N, okay, which is on the same indifferent curve, which is IM, okay, and it's costless. Okay, so part A asking you, which do you think Gabrielle should do? Maintain expenditure and buy a bundle that she prefers M, or in C, where she, as in C, or she wants to reduce expenditure while buying a bundle in the set IM. Okay, so basically the question asking you, what should the consumer do? Should they consume bundle N, or should they just consume a bundle something like say somewhere like this, say I would say bundle A, bundle O, okay, so something like this. Okay, so bundle O over here is in part B, where in part C, where we say that the consumer can actually buy something better than bundle M, okay, and still affordable. So should the consumer buy O or buy N? Okay, now what we care about is the utility for the consumer. The higher utility, the better. Okay, so the consumer would want to consume a bundle such that the utility is maximized. Okay, so therefore the consumer would want to spend to maintain the expenditure. So basically they want to be spending the maximum amount of income and be on a higher indifferent curve rather than buying point N over here, the consumption bundle N over here. Okay, so like I said, the higher utility the better. So if they can buy any bundle that will give them a higher utility, they would do so. Okay, so they would rather just use all of the money, buy all of the consumptions and increase the utility. Okay, so what a consumer should do is to maintain the expenditure and buy a bundle that she prefers to earn, because that is going to increase her utility. Okay, so outside consumers should so maintain the expenditure, so keep spending everything she has, okay, which is going to pick a bundle on a budget constraint. Okay, so pick a bundle on the budget constraint. Okay, and consume a bundle that she prefers to M, and this is because the higher the utility for the consumer, the better for her. Okay, alright, so if anyone is curious about what bundle should she pick, then as you can see, that is going to be the tangency between indifferent curve and the budget constraint. Okay, we want her to be spending on her budget constraint, which is the black line, and on the highest indifferent curve possible, and that is going to be the bundle over here. Okay, so this is going to be the optimal bundle for her. So I would say this is bundle okay, and this is the optimal bundle for the consumer, because that is the bundle where she's on the highest indifferent curve possible. Okay, so as you can see, bundle O over here is better than bundle M. Okay, however, it is still not as good as bundle K. So we want her to be spending all of her money and on the highest indifferent curve as possible. Okay, so corresponding to bundle O, as you can see, the indifferent curve going through that is going to be something like this, which is lower than the indifferent curve for bundle K. Okay, so bundle K over here is the optimal bundle for the consumer because it's on the highest indifferent curve and it is on a budget constraint, which is affordable for the consumer. All right.